Okay, sorry for the delay, everyone. You can get started now. Welcome to the 10th workshop for CPP Hyperloop, Spring 2023, Season 4, 4x10. This is the flight control workshop. This is a one-of-a-kind workshop, the first of its kind in the Hyperloop series ever, and it's all about drones. So we'll talk about what drones are, why drones are important, how we can work with drones, and in about an hour, you guys will get to fly your own drones out in the engineering meadow. At the end of the day, we'll have a drone race in which you will get to fly drones through an obstacle course made out of these fun little rings here, and you'll race each other, and the winner will get a special prize. So this lecture will cover a bunch of safety tips and how drones work and different types of drones, in the hope that it will inspire you to start working on drones of your own, or if anything, it's just a fun little workshop to get your feet wet in the world of aviation. So let's get started and start talking about apparently nothing. Drone utility. So in this section, we're just basically introducing drones. If you guys have never heard of a drone before, what it is, why it's important, and why as a society, moving towards this kind of technology may be beneficial for us. So first of all, what are drones? Now, I'm sure everyone knows what cars are, right? They are things, or they are vehicles that move on the ground. Well, drones are kind of like this. They're like personal, tiny little vehicles that instead of moving on the ground, they move in the air, right? Usually on drones, you have some kind of propulsion system like propellers or jet engines if you're talking about airplanes, that lifts it off the ground and it's able to self-sustain itself in the air. Now, there are multiple types of drones you can get, such as quadcopters. We have a quadcopter right here, and quadcopters are distinguishable by the fact that they have 4 propellers. So you can see 4 propellers right here. You also have vertical takeoff and landing, or VTOL-like devices. A lot of the UAV projects here on campus actually deal with VTOL-like devices. So if you want to have a fun little senior project, you can do that. You can have single rotor drones, which are also known as helicopters, right? Helicopters have that one big rotor on top, and they can use several positioning methods to steer and whatnot. And also you have tricopters and hexacopters. These last two are just variants of the quadcopter, and this picture right here actually will show you the difference between them. Tricopters and hexacopter just have different amounts of arms that it has. And tricopters are fun little drones because the balancing methods and keeping it in the air are different. Hexacopters are also fun because there's a lot of blades. It uses a lot of power and it's a beast in drones. So it's very easy to get up in the air because the amount of propellers that it has and the amount of arms can give it a lot of thrust. So those are just the different kinds of drones out there. A lot of hobbyists will go for like a quadcopter. Maybe if you have like sort of like a commercial drone, and I will use the term commercial drone to describe drones that, what did I put? Oh, here it is. I use the word commercial drones to describe drones that you can just buy off the shelf in like a store, like this Parrot Anafi drone, or a hobbyist drone, in which this Pixhawk powered drone right here is a hobbyist drone. So multiple different types. So what are drones used for? Now this part is important because if we have flying vehicles, flying personal vehicles that can do many things, they'll be helpful for society. Well, the first reason we use drones are for fun. There are a lot of toy drones out there because they're a novelty to many engineers and many students and just people in general, right? If you go into a Toys R Us, you can find a toy drone. It might not work that well. It might crash, in under 10 seconds, but it's still there to get people engaged. It's just there to provide entertainment value. So I think there was someone in the audience who has flown a drone before and said it was like not a very expensive one. It's probably like a toy drone. And in fact, the drones we're gonna be using today are toy drones. This is the DJI Tello. And it's kind of like the gateway between a toy drone and an actual drone because this is the programmer's drone. You can actually program this to do things that you want. So we'll talk about that later, but now, several other applications. Now, if you go into any of the senior design projects here at Cal Poly Pomona, you'll be tasked with solving a sort of problem statement. And usually this problem statement can vary between things like saving someone that is lost, or helping someone that is in need, or finding things in a unknown area, or something that will be able to be solved using a drone. It always boils down to that. Now, of course, SDPs or senior design projects don't just have to be encapsulated within drones. I'm just giving an example. But one of the main problems in today's society that we can solve with a drone is search and rescue missions, right? If someone is lost in a forest, it's much easier to find them if we fly a drone up in the air rather than search on land. So that's the idea behind that. And a lot of the search and rescue missions these days already use sort of like a drone to find people. They use the single rotor helicopter, right? That's sort of a drone as well. But if we can boil that down and make it much smaller and make it so that a human doesn't actually need to be in the vehicle to control it, it'll be much more efficient. So the term efficiency is going to get tossed around a lot here as well. The second thing, and some of you may have heard this actually, is package delivery, right? We can use drones to deliver packages to people. How many of you guys have heard that Amazon might be unleashing a new package delivery drone sometime soon? Right? Actually, they said that like 4 or 5 years ago. They're like kind of into that. But as we can, we'll talk about this a little bit later, but there will be some restrictions as to why we don't have that sort of delivery these days, as to why so far we still have trucks delivering our goods or planes delivering our goods. But, drones can actually be used to deliver packages. And we actually call this, if we put something like heavy on the drone for it to carry, we call it a payload. And a lot of drones have a maximum payload or the amount of weight that it can carry. Is that my computer? I'll fix that later. So in essence, we can deliver packages using these drones. But there is a good reason why we don't use them to this day. We can also use them to investigate resources. So if we have an unknown patch of land that is dangerous for humans to go into, sort of like a radioactive nuclear plant, for example, humans won't be able to go into it because obviously it's dangerous for them, but we can fly a drone into it with a camera that can scope out the area, see what's up, see what's good, right? So resource investigation, also a very good way to use drones. Environmental monitoring, oh, this one's good. So many applications these days, or many farmers these days, actually use drones to use as surveillance for their land. So they can dispatch a fleet of drones to go look at a patch of strawberries, for example. And then the drone's intelligent camera system is able to pinpoint which strawberries are bad and let the farmer know exactly where they are. Again, increasing the efficiency and productivity of work. Drones are very efficient. Actually, before I go into the next one, the picture on the right is actually a study by Maxar Technologies in 2020, in which they use drones to find out where bird nests are in a large field. Because again, it'll save human time for looking through it and tell them exactly where they are so they can take care of the birds' nests or remove them or do what you will. The next point is law enforcement and surveillance. Now, I know some companies that already have started switching to drones as a way of looking for bad guys that try to break and enter their field or their company or their whatnot. And it's a better way of looking for bad guys because, again, drones in the air, they can see a lot of things at once. So you're not limited to the height that a CCTV camera might have if it's placed on a building next to a ground area. And finally, urban planning. Oh, this one's a fun one. So a lot of civil engineers will use drones in order to scope out some lands to figure out exactly where things are and where things should go. It's kind of like The Sims. If you guys ever played The Sims, it's kind of like looking at everyone from a top-down view, dragging and dropping houses and seeing where everything should be, what every road should be, where every junction should be. It's very fun. And there's a ton more, but I don't have enough time to cover everything. Yeah.
I just need to go make a phone call.
Oh, go ahead. No worries. Yeah, while you do that, I'm going to actually turn off my Discord. Okay, so now that we talked about like all the things that the drones can do, the big question is, why don't we already use these drones in today's society? Like, if there's so many great things we can use drones for, why don't we already use them? Here's a list of reasons why. First thing is cost. Drones are expensive, like crazy expensive. This drone right here, anyone want to guess how much it costs? Oh, now that I told you it's expensive, you're overballing it. This drone's actually $1,000. So this drone, and we'll talk about cost estimations later and that sort of good stuff. But this drone is actually not that expensive. It's $1,000. This is a handmade drone. So if you were to buy a commercial drone, which kind of like this is actually $400. So it's much cheaper, but I bought this one because it had a 4K camera and I had a 20% deal off on Amazon, which I know is probably a scam, but I wanted it. So we have several drones here. Also, this one's $100, and hopefully by the time we end today, I can inspire you to try to get one of these yourself. These are pretty cool, and they're very, very inexpensive too. So, but if you want a drone to be doing some sort of like application we saw in the previous slide, if we want a drone to do surveillance, for example, or environmental monitoring in which it uses artificial intelligence to scan a field, that drone will need an expensive camera. That drone will need a long battery life to travel places. So those additions to drones, like a camera that can do that sort of stuff, is around $35K. I mean, Boston Dynamics charges that for their robot dog. So it's very, very expensive, and the cost can stack up because a lot of these drones are modular, in which you can attach extra equipment or upgraded equipment to them to make your experience a lot better to use. So again, cost is a big factor in why drones can't be used today. And I just covered the second one, complicated technology. Some things that need to be attached to drones, have a risk of breaking. And I have faced this with this drone a little bit too many times. On the bottom here, this is a GoPro mount, and GoPros, as you know, are not cheap. The one I have in my backpack right now, or my box, is around $300. So if I were to attach this, I would be basically suffering the risk of breaking the GoPro in case my drone gets into a big crash, right? So that's kind of like the same kind of ethical concern for other people. If I want to upgrade my drone, I have to make sure everything works and everything is stable and the technology can be easily replaceable before doing something else. Because I don't want to put like a state-of-the-art camera that can only be made once into a drone and then have it crash. That's the concern there. The third one is also a major, major, major concern, right? In our world, we need to have laws. And if we don't have laws, then we basically live in a lawless society in which anything and everything will happen. I'm just checking that my microphone is connected, which it is. And so the FAA is kind of like the organization that controls what can fly and what can't fly. You might know them from airplanes, in which they kind of like control like the air traffic and say where the airplane should go precisely and at what time. But for drones, since they are flying, they encounter the same rules and regulations. And if you don't follow this FAA guide, the government will get mad at you and they might lock you up and put you in jail. So the reason why we don't have drones spamming the air these days is because the FAA is basically going to say no. It's going to say, Amazon's going to say, I want to put 50 drones in the air in Los Angeles to deliver packages to people. The FAA is going to say no, because these drones are going to cause a disturbance in our society. These things are stupidly loud. Let me get you. Drones are not silent, right? And if you turn one of these puppies on, it's basically going to sound like there's a jet engine like right above your house every like 5 minutes. And they're not going to have that, right? They don't want to disturb society. In addition, if you have enough drones in the air flying at a certain height, they might start to crash into each other. Unless you can get control of how every drone flies autonomously, because most likely these drones are autonomous. They're not going to manually fly a drone. There needs to be like airway tunnels in which these drones can operate on in order for this to work smoothly. But currently, we don't have the logistical technology to do that yet, which is why law is going to prevent you from flying your drone. Next one's limited flight time. And limited flight time is actually part of my senior design project, in which I will explain the whole prompt to you in the next slide. Because drones cannot fly for a long period of time. They run on batteries and not jet fuel, for example, right? Airplanes can fly for a long period of time, like 8 to 10 hours almost, because they run on fuel and then you can convert that into energy, which powers its engines, which makes it fly. Drones aren't like that, right? If I have this thing powered on at all times, each of the 4 motors needs to spin all the time to get it into the air, right? So it will drain a lot of power. And these batteries can only power the drone for about 15 to 20 minutes max, right? This battery is not that strong. And for the most part, a lot of drones are kind of like that. Their maximum flight time is probably below an hour to this day. Like, we don't have the technology yet to extend the flight endurance. So senior projects and people who write papers and theses and dissertations around the world have found ways to try to save this, right? Save the limited flight time problem. But so far, unless we can find some new way to get longer flight time in drones, it's going to be not feasible for it to fly a long distance, let's say from Los Angeles to New York. Finally, efficiency, right? Efficiency is how much work we can get done in a short amount of time. If we don't have our output, our work output, be high enough to compensate for the amount of time and effort we put into making drones happen, that's not going to be a feasible solution for us to implement this kind of technology into the world today, right? So again, efficiency is very important. If we decide to implement drones, we want to make sure they can do work for us. We want to make sure they can do a lot of work for us and not just be there as sort of like an expensive paperweight, which I've crashed these drones before. They can be expensive paperweights. Okay, oop, oh, well, I'm gonna expose this to you, but again, drones are limited by a lot of factors, which one of the main ones is that they're limited by their battery life, right? So just a thought question for you out there, and I had this set on like where it would show the paragraphs line by line, but how would you extend the flight time of a drone? Just a question for the audience. You can make the drone smaller. Actually, that's not on here. That's a good one. Yeah. So if you made a drone smaller, you would decrease its weight, which makes it need less power to fly, which is a good solution, actually. Anyone else? I'll go over the ones here. And so the big problem with a lot of drones, if you can't make it smaller or you can't adjust the size, is the battery size or the battery capacity, right? How much charge can the battery store? And this is kind of like a paradox I like to talk about. So if the battery size or the battery capacity increases, then it means that our flight time also increases, right? But what's the problem here? If we increase the battery capacity, what also has to increase? The weight also has to increase, right? The battery gets bigger, the weight gets higher, which means the drone will now need more power to fly. So you can graph this on a curve, but there is so much you can increase the battery size by before it becomes too inefficient to operate. Be careful about that. So if we can't increase the battery size, what else can we do? Maybe solar panels, right? If we attach solar panels to drones, then as it flies, it can take in power from the sun and feed it into the battery. Biggest problem about this, really, and my mic is twisting, so the Zoom is going to have fun audio. Biggest problem about solar panels is that they don't charge fast enough, right? Because these motors, they draw a lot of power, and solar panels aren't going to cut it when you are basically using the equivalent of a blender in the sky all the time. What about charging off a power line? It sounds illegal. Probably is. But you're basically stealing power based on the current traveling through a power line. If you guys know anything about electricity, right? In the city power, we're powered by AC, right? AC current travels through the power line in order to give us energy. And this current that travels through the power line generates magnetic fields, for those of you who took like 1520 in physics. And so the drone is able to use those magnetic fields to induce power on its system. It's kind of like a magic trick. But again, probably illegal, probably dangerous, because if the drone gets too close to the power line, kaboom, right? You don't want exploding drones. So charging off power line might not be the best solution either. What about battery swapping, right? If we had the drone land on like a ground station, just entirely replace its battery and fly off again, then we're basically replenishing the battery in like 1 minute, 2 minutes, and it can fly again, basically doubling its life or tripling its life or ad infinitum. The problem with this is that you would need like several physical ground stations laid out at several destinations, kind of like how Tesla superchargers are, right? We have more electric cars now. They're kind of like drones, they're powered by electricity, but electric cars like drones, can't drive forever. After like some amount of miles, it loses its charge and has to recharge again at a Tesla supercharger station for like 20, 30 minutes. So that's the deal with that. What about using a more efficient drone? We talked about vertical takeoff and landing. And the benefit of these drones is that they have large wings, like a really large wings, like an airplane. And these large wings allow the drone to kind of take off and then just glide. Like when it travels through the air, it might not need to turn on its motors fully, because that gliding motion is just based off the shape of the wing. That's an aerospace question right there on how to make that more efficient. But this VTOL-like system will still drain battery. So again, overall, a bunch of things you have to think about when you're trying to make drones fly for longer. How to eliminate that limitation in order to get more efficient flight. Okay, how many of you guys have seen this video? Seen it, but haven't watched it yet? Okay, so this guy, Mark Rober, went ahead and interviewed this company called Zipline. They have this innovative technology of delivering things to people in a new way using drones. And so I'm gonna go ahead and play this video just for like 1 or 2 minutes so you guys can get an understanding of the applications of drones used in today's society, and then we can move on. Let me just make sure my Zoom is sharing sound. Okay, good. And let's watch this.
I cut my finger making lunch, so I placed an order for some Band-Aids a couple minutes ago, and now they're 4 seconds away. That is a nearly silent drone system that can deliver a package from the sky right to my backyard in as little as 2 minutes with dinner plate accuracy. And as far as I'm concerned, that's basically teleportation. This is the very near future of package delivery from a company called Zipline. It's been over a decade since we were first promised drone delivery that looked like this, and to be honest, I was never that stoked about it because I couldn't imagine that anyone would actually want something that big and loud with dangerously fast spinning propellers landing anywhere near their house. And that was a bummer, because with the explosion of people using Amazon or food delivery apps like DoorDash or Instacart, billions of doorstep deliveries are now happening every year. But when your lunch only weighs a few ounces, driving it to everyone with these 2-ton gas-powered vehicles is wildly inefficient, bad for the whole planet, and not to mention just really slow. Drone delivery would not only take a lot of cars off the road, but it would be a lot faster than a car, it would be fully electric, fully autonomous, and it would cost pennies worth of energy per delivery. And with Zipline, because the droid that lowers the package can move laterally in any direction, it can make a dartboard-sized precision landing even in high winds, while the main drone can stay 400 feet up in the sky, making the whole thing whisper quiet. That is very quiet. Also due in part to the clever design of these really funky propellers. As you all know, I only make about 10 videos a year, and while most are just sort of ridiculous, I like to dedicate one video to showcase how clever people are using engineering to change the world for the better. And to be clear, the company I'm talking about today is not sponsoring this or paying me in any way. I'm just really impressed by the work that they're doing and how they're doing it. So we'll circle back in a minute to exactly how they're going to pull off deliveries using these short-range drones in a city, but
I'm gonna stop it there, but I think that's just a really cool application of drones in today's society. Like, they're nearing deliveries. Like, this thing solves the issue of drones being really loud by just lowering down in pod. And it also solves the issue of speed because, you know, these drones that Zipline makes are really quick. So I'm gonna go ahead and move on.
I cut my finger making lunch.
Now, for the recording, if you're watching this on YouTube later, that part's gonna be cropped out because of copyright infringement policies. So you're not gonna be able to see that video. But if you want to view it, just Google Mark Rober Zipline drone video, and you'll be able to see it in full. And for the rest of you, you can look at the full video online as well. I think it's really cool. Anyways, this next section we're gonna be talking about the anatomy of a drone, or as I like to call it, flight architecture. So, exactly how are drones built, or what parts go into a drone? Because understanding the different parts of a drone will get you more information as to how exactly it all works, how drones actually fly. So the first thing we're going to be talking about is the flight computer. Now, for the most part, as I'm explaining this section, I will be covering the $1,000 quadcopter that I built, this little thing right here. Now, most drones, like the Parrot and Nafi, aren't going to be as expansive and open as this. There's a bunch of wires here, right? Compared to this drone, where everything is basically enclosed inside of this cute little package. Now, basically whatever I'm going to talk about now is located on every single drone's motherboard. But some drones, like this one, are a lot more spread out and modular, like you can plug stuff in, it's like plug and play, than others. So you have to be careful about where you take this information. Just know that this is for this drone, but a lot of the things I'm going to be talking about, the electronics, are going to be placed in commercial drones. You just can't see them as often because, you know, sleek design makes the money. So the first thing is the flight computer, and the flight computer is essential for every flying device, essential in the way that you can't actually operate a drone without it. It's the computer, or the brains of the drone. And when I say computer, I mean this computer can perform autopilot, it can do autonomous flight. It runs a lot of calculations in order to turn your user input into things that the drone can understand. Because when you're controlling a drone using something like this controller, you can't just tell the drone to go like to the right and the drone will respond. Well, actually that's how it works, but the signals that are being sent to the drone's motors don't actually process that. They don't understand go right? It's got to be in a specific series of signals. So the flight computer will basically translate the signals sent from a controller into things that the drone can understand, right? And that's what we're going to be talking about next. But in this case, this right here is a Pixhawk. This Pixhawk is kind of like the default flight controller that is used basically everywhere. And it has a bunch of ports. As you can see here, we see receiver, telemetry, USB, LED, SPI power modules, buzzers. A lot of ports so that you can connect it to what's known as peripherals, like extra things that will give extra functionality to drones. Kind of like analogy here. If this were the brains of the flight computer, like this was my brain here, you would plug like my arms, you would plug my legs, you would plug a heart into it, you would plug my mouth, like the buzzer, it's kind of like my mouth, it talks. But it's things that you plug and play into the system for it to be able to use correctly, right? And this right here on the right is the Navio. It's kind of like the other popular flight controller, except this one's made for attaching itself onto other computers. It's not exactly self-sustaining. So you can see this one's strapped on top of a Raspberry Pi, and this is actually the advertisement panel for it. I just screenshotted it. And you can see all the features it has, sort of like it has a GNSS receiver, dual IMU. The IMU, or the inertial measurement unit, is what actually balances the drone. So that's one of the key features for the Navio. That's why it's so popular. It also has a coprocessor, some other cool stuff. Basically, it's compatible with the Raspberry Pi, and you can connect that right one to the internet. Can't connect the left one to the internet, though, unfortunately. So we talked about the brains of the drone. Now let's talk about the arms and the legs of the drone, or the things that actually get it to fly, the motors and the ESC. Now these, although they're dumber than the brain, it does need motors and ESC in order to be able to function correctly. Now the motors that we're going to be using are brushless motors. Brushless DC motors are three-phase motors. Pretty much, you can see to the left here, there's three wires that come out of the motor. Now, these three-wire motors are a little hard to control, and so you need something called the electronic speed controller to control it successfully. As you can see, the bottom diagram there shows what actually goes on in an ESC. It's a lot of complex technology and a complex mechanic that controls the motor. So all you have to understand is you put a signal into the ESC, and it can either drive the motor forwards or backwards. And the signal can appear as a pulse width modulated signal, which is pretty much looking like a square wave with different high and low set points. So if we feed a signal into the ESC, it will power the motor for us, but we can't directly connect the motor to like a power source and power it up, because that won't work, right? You have to send a specific series and pattern of signals at different timings into the motor to get it to turn correctly, because it's three-phase. And so you can see here on the top here what it looks like to actually try to control one of these motors inside the system. Now this right here is the brushless motor on the top, and you can see it's connected to the ESC via three wires. Now you'll notice that drone has four motors, so it needs four of these ESCs, right? And so you can see the control wire, or the signal wire, being connected to the Arduino, and the Arduino can send a signal into this wire to control it. And a LiPo battery, a big LiPo battery pack, is connected to the ESC. and the ESC takes the main power and the signal and uses them to control the motor. That's the control diagram right there. That's the easiest part of that slide, by the way. But you'll notice that drones have 4 of them. Now, we're going to be talking about propellers next. And propellers are these little plastic pieces on top of the drone that actually provide the drone thrust and can allow the drone to fly. There are a lot of different types of propellers, but the main factors that can affect the flight are the length of the blade, the number of blades, and the weight of the blades. Now, you might be wondering, if I want my drone to fly for a longer or stronger period of time, why don't I just make the propellers huge? Like, why don't I just put this on this, right? Why don't I use more blades? You know, why don't I just use the red blade, which has like 6 all the time? And the issue is because the longer you have your blade, the more propellers you have, you will get more thrust, right? Don't get me wrong, you will get more thrust, but your battery will also reduce a lot faster than if you just use less blades, right? So again, efficiency here. We want to provide the most work while providing the least effort. So more blades will give you will need more power, and essentially you won't get the correct output you want. LiPo battery. Okay, let's talk about this. LiPo batteries are the essential power. It's kind of like a 9-volt battery, except it's much more powerful, right? It's basically like food for the drone. You gotta feed your drone with food before it can fly, so this is kind of like that, right? It provides a lot of power very quickly to the drone at all times. This battery up here is one of my favorite batteries to use right now. This is a Turnigy 3S LiPo battery. You'll see batteries characterized by a number and then S. That's what you want to look for. And that tells you how many cells there are in the battery, because this picture over here up to the right shows you exactly what's inside that battery. This is 3-cell LiPo battery, which means 3 cells are connected in series, which provide the battery with a set amount of high voltage. Now, each of these cells in a LiPo battery, it stays consistent across the batteries that you use, has a maximum voltage of 4.2 volts. So if we have 3-cell batteries in here, and we try to measure the voltage at this end, what do you think the highest voltage is going to be? For those of you who don't know electronics, I'm sorry. But all you gotta do is you just gotta add the voltages, right? If we have 4.2 volts here, 4.2 volts here, 4.2 volts here, you add them all together, you get 12.6. So the highest voltage in that battery is 12.6 volts. Now, it's not good to store the battery at the maximum voltage all the time. So a lot of times the storage voltage is actually the safe one you want to go for. And these batteries have a storage voltage per cell of 3.5 volts, right? So if we have storage voltage for a 3-cell LiPo battery, what's the full voltage going to be if we add up all the cells? 10.5. 10.5, yeah, exactly. So when you buy these batteries off Amazon or off Hobby Power or Hobby King or whatever that you buy off of, you want to make sure that the voltage is at 10.5. Because if they ship it at the max voltage per cell, you get a chance for it to explode. And these things explode, by the way. These things explode, they catch on fire, they're very volatile, because these batteries have a high discharge rate, right? You can draw a lot of current from them very quickly. Now, the dangerous part about this battery, and please remember this from this lecture, because a lot of times when I'm working with students in senior projects, they mess this up all the time. The dangerous voltage is when each cell goes lower than 3 volts. Because what happens is these batteries are rechargeable, but if you get them lower than this voltage, they start to die. Right? It's kind of like malnutrition. If you don't eat enough, you will die. So the dangerous voltage is 3 volts. So 3 volts per cell equates to what volts for the entire battery? 9 volts. If it goes under 9 volts, you're in big trouble. Because each battery cell will start to die off. It'll start to become less efficient. It's not going to store enough charge, etc., etc. So now that we talked about cell voltages, let's talk about charging and discharging rates. When you're buying these batteries, you always have to look for the letter C, because it tells you what the charge and discharge rate is. C is equivalent to the rate it discharges or charges divided by its capacity. Now, capacity is usually represented in the format milliamp hours or amp hours. And for this battery right here, it says 5.0, so we can determine that this battery has 5,000 milliamp hours of capacity. Now, the charging rate tells you how much current you can grab from the battery at any point of time. right? So if we can say that this battery here, I can't read it, but I think it has 50C, right? So let's say it's 50C, then its rate is going to be the capacity times the C value, so 5,000 times 5, which is equal to 25,000. 25,000 milliamp hours, which is 25 amps, right? So that's the discharge rate, and its charging rate is usually much smaller, like 1C maybe. So in this case, if my charging rate, or if I wanted to find my charging rate, and I had 1C as my charging rate for that battery, what would my rate be? So if the capacity is 5,000 milliamp hours, my C is 1. Yeah, so you got to charge this battery at 5x. That's its max charging rate. To connect these LiPo batteries to the rest of your system, you can use XT60 or XT90 or T-plugs. Those are the most common ones. For these kinds of batteries, usually it's going to be XT60. These are the yellow plugs you see at the ends of the drones. And for tinier little drones like the Tello, they actually do use LiPo batteries, but they come in different packages. It's usually coming in like tiny little ones like this. You pass it around, it's not gonna blow up on you. And these batteries are great because they're small, they're compact, but if I have a smaller battery, what am I losing out on? Capacity, yes. So these only have 1,100 milliamp hours of capacity. What else? I'm going to lose out on this, right? Discharging rate. It's going to have a lot lower discharge rate and a lot lower charging rate. So that kind of sucks, but at least it's a small package, right? Like you said, smaller drones can last longer. So it is a good fact. Okay, so whenever you're using a LiPo battery, if you're ever using a LiPo battery, just be careful at what voltages is. Every single time I use a LiPo battery, or I actually have what's known as a voltage tester in my LiPo battery. While we're talking about safety here, by the way, we just need to make sure that we're very, very safe when using LiPo batteries. And this is a anti-flammable bag. So if a LiPo battery explodes inside this bag, we're good, because the fire will be contained inside. If I open it up, you can see that I stored a couple things in my LiPo bag. I stored a charger in case my LiPo batteries run low. Come on. And if you guys start using LiPo batteries, I recommend you get one of these chargers. These are balance chargers. They're very good because you can set the charging rate or charging mode, and they will keep your batteries nice and healthy. Because batteries are kind of like a human, right? I also have LiPo batteries in here, and a voltage tester. That's not a voltage tester. This is. So if I don't know exactly what voltage my battery is, because again, if it gets too low voltage, it'll explode or burn on fire or just swell up and be extremely dangerous to watch. So all you gotta do is get one of these things. They're like a buck on Amazon, and you can plug this JST cable. Every LiPo battery, or a good one at least, should come with one of these because, like this cable right here, it connects to every single cell. So it will tell you the voltage that's inside every single cell, right? Again, if the voltage is too low, you're in danger. So if I plug this into the battery here, there'll be a loud noise, sorry. Try to muffle it. So you can see here that it's going to tell me the voltage inside each of the battery, right? It's going to be saying that this battery's at 12 volts right now, which means, is the battery safe? Yeah, right, because it's more than 9 volts, more than the danger zone. But this display is pretty cool, and it allows me to make sure that my batteries are safe at all times. I would pass this around, but this is more dangerous than the other LiPo batteries, so I'm just going to keep this. Yeah, so LiPo batteries come in all different shapes and sizes, and I will show you guys what I mean by the fact that if you have a larger capacity, it's usually a larger battery. This LiPo battery here is a 4-cell LiPo battery. It is a 4,000 milliamp hour LiPo battery, so the capacity is 4,000 milliamp hours. Now compare that to this battery, which is also a 4-cell battery, but it's much smaller. It has 1,500 milliamp hours. That's more than like half of what I showed you before. It's a fun little thing. Okay, I spent a long time talking about LiPo batteries, but it's for a good reason. It's the #1 reason why fires happen, or things happen that kill the LiPo battery. Again, this is analogous to like a human, right? If you feed the human, it will survive. Like if you feed it, if you charge it when it's low, if I'm hungry and I feed myself, I will survive, right? Now, why is the max voltage, if you store it at max voltage, why is this bad, right? And the easiest way to explain it is if you stuff yourself, right, with food, and then you go to sleep, you'll eventually feel bloated when you wake up. It's kind of like the same thing. If you feed it too much and you leave it alone for like 6 months, and you come back to life battery, you'll find it has been bloated, right? And it's out of shape. It's kind of like a human. But again, don't store it at max voltage, don't store it at lower voltage, because either of these will kill the battery, right? If I feed you too much, or if I starve you, you will die. Just right, 3.5 volts. All right. Does that make sense to everyone? Cool. You are now all LiPo battery experts. Okay, the next thing that's on almost every drone is what's known as a power distribution board. And this board looks pretty cheap, but the whole goal of this is to get the power to all 4 motors, right? We only have 1 battery, which means we need this 1 battery to power 4 things, actually 5 things, right? If you count the flight computer. So this board takes in an input, which is my LiPo battery. Again, this is the XT60 connector, and it goes into this PCB. This is a BEC. A BEC stands for a battery elimination circuit. It basically takes the input voltage and drives it down to where you can power a flight computer with it. So the flight computer will not be able to see the signals going to the rest of the motors, right? You kind of want to block it off. Because if the motors burn out and you have too much current going on one of these lines, you don't want your flight computer to also burn out, right? Kind of like if you break an arm, you don't want to break your brain, I guess. So this is really important. And if you take a look at this diagram on the right here, this actually shows you how everything is connected. So kind of putting it all together so far. We can see here this power distribution board is connected to the main battery via this XT60 cable. And then we connect this power distribution board to the ESCs, the electronic speed controllers, which are connected to the motors right here. And we can see that our flight computer is being powered off by small signals. Top. Don't remember the rest of the stuff. Just, you can see how this power distribution board allows everything in the drone to be powered all at once, very evenly, very safely. Because, again, we don't want our drone to blow up. That'll be bad. Next thing, the GPS. If you're making this drone, it's very highly recommended that you get a GPS. Now, this is not mandatory, but it kind of gives the drone an understanding of where it is at all times, which is very, very helpful if you're trying to do autonomous flights, right? This concept is known as localization, when you give a robot understanding of the world around it and its position in space. Now, there are a lot of GPSs, but mainly they can connect to the GPS port on the Pixhawk. You can have 2 GPSs if you want, and they communicate using these wires. But GPS is very important if you want to ever do autonomous flight, because otherwise, it just won't know where it is. Now, if you have like less complicated drones, like the Parrot and Nafi, actually this one has a GPS. This one does not have a GPS. So how would it know where it is in space, right? If it doesn't know exactly where it's positioned, right? It can't look at a satellite to see where it is. How does this drone know where it is in space? You know? I'm pointing it to you. Yeah, the drone has a camera, right? So this drone actually has sensors instead of just a GPS. A GPS is a sensor, by the way, but this Teledrone, because it's so cheap, it only has a camera and an ultrasonic sensor on the bottom. You know, but we're not going to make it fly across the Atlantic Ocean, right? So we're okay. So GPS works by pinging several satellites that are in space and asking it, where am I at all times, right? So you need to make sure you have a good satellite connection before you can start flying. And when we talk about flight modes, I'll explain the importance of GPS. This is a receiver. This receives signals from a controller. So if I'm trying to control my drone, I want to make sure it can receive the signals, right? So this module will take signals from my controller and map it to the drone. Now, receivers have a set amount of range, so you can't just go fly the drone to infinity and beyond, because at some point you'll lose signal on your receiver, right? This sends out data using like radio waves and at a specific frequency. Actually, the frequency is 2.4 gigahertz. But radio waves in order to connect with a controller so that you can fly your drone autonomously or manually if you want to, right? On my drone here, it's just this green little module down here. And receivers can come in all different shapes and sizes. This one on the right is like really tiny. Data transceiver. Okay, so this one is important because if you're trying to do autonomous flight, you want to connect your drone to a ground control station or somewhere on the ground where you can like see the data from the drone. So in this case, we're just using 2 big antennas, 1 small antennas, and some of these actually have a visual interface to your computer, or you can plug them into your computer and see the data come from there. And buzzer and safety switch, some drones actually have this as kind of like a safety measure and to indicate to the user like what's going on, right? Because when we talked about designing PCBs in previous workshops, we always stress the importance of user validation or letting the user know that they know what's going on in the drone at all times. And this buzzer is kind of like that. The switch is used for safety. So in Autopilot flight stack, which is a specific flight stack, the button is used for making sure that you're for sure ready before flying. So you need to press and hold the button, the buzzer makes a sound, and that basically lowers the failsafe and allows you to fly. Come on. Okay, let's talk about firmware and software. If you want to power one of these complicated drones, you need to make sure you have the right firmware and software before you fly. Firmware describes the code that is located on the drone itself. So in the flight computer, you can use either Autopilot, PX4, or if you're doing this on a Raspberry Pi, you can use Dreamflight. Dreamflight is a cool little software that if you want to ever create a drone based on just a Raspberry Pi and like a tiny little IMU board, you can. Developed by some open source guy, he's real cool. In order to fly the drone autonomously, you can use the ground station software. So you download either Mission Planner or Q Ground Control onto your computer, and then you can use the transceiver, the data transceiver, to see exactly what parameters are on your drone at all times. So the diagram to the right is known as Mission Planner, and you can actually plan autonomous mission by dropping waypoints onto a map, right? And this will send the data to the drone through Mavlink packets, and the drone will actually follow this pentagon. Is it a pentagon? I think. The pentagon if it was drawn by ChatGPT. Okay, so, oh, come on. I think my computer's lagging on me. Okay, I'm going too far. So, putting everything together. When you're building a drone, this is always going to be the most stressful part for a lot of people because it's a lot of hardware, and you need to make sure that everything goes where it should be, right? We started with talking about the flight computer, which is in the center. Then we talked about motors and ESCs, which is over here. Then we talked about batteries. Then we talked about receivers, transceivers, like the, this is a data transceiver. We talked about GPS, and then the safety switch and the buzzer. So if you put all of these things together and connect everything in the right places, your drone should fly. Not really, you still need 2 minutes. But drones like this, commercial drones like this, have everything here, but just in a small little PCB. That way, they can keep the shape of the drone very elegant and very neat, compared to this monstrosity. This looks like I Frankenstein everything together, which I did. Okay, now let's talk about flight control. And this will go into how you can actually fly a drone and the things you need to know before you fly a drone. The first thing is the common control. So when you fly a drone, we'll use this terminology to determine where the drone goes. And I'll use this drone to demonstrate the flight controls. So you need to know where the drone's heading is at all times. And what heading is where the drone's pointing at. So if my eyes were at the front of my head, I'm going to call this north, where my north is at all times. So if I looked right here, then this board is going to be my north. This board is going to be my heading. Same for the drone. If the drone looks somewhere, that's its heading. So when you control the drone, everything is relative. Right? So for a drone, if I'm pointing this drone to you guys, actually I'll point it away from you. I'll point it away from you and towards this obstacle here. Look at that. So let's talk about common controls. Throttle is going to be our control for moving the drone up and down. So if the drone's throttle increases, it will go up. If the drone's throttle decreases, it will go down. It's pretty easy so far, right? Yaw represents z-axis rotation. So if we drew a z-axis up and down, actually I think that's y-axis. Okay. This axis that goes up and down, depending on which axis you're looking at, it will rotate around it. So this is yaw. So if you wanted to observe the drone rotating in the air and do kind of like a panoramic view of Cal Poly, you would fly the drone up, you would increase the throttle upwards, and then you would increase the yaw as it rotates 360 degrees, right? Pitch and roll cause the drone to go right, left, forward, and backwards. So if I were to increase the pitch would make the drone go forwards like this into the ring. If I decrease the pitch, it would go backwards like this, right? So increase pitch, decrease pitch. Roll is going to go from side to side. So if I increase the roll, it will go right. If I decrease the roll, it will go left. All right? Now this terminology, again, when we're trying to control a drone, the drone doesn't actually understand any of this, right? We use what's called human mapping, this is my terminology, it's not official, in order to make sure that the drone understands where we want it to go at all times. So if we want the drone to go forward and backwards, that's pitch. If you want the drone to go right and left, it's roll. And if you want the drone to go up and down, it's throttle, right? If you want it to rotate in the air like this, it's yaw. Everyone got that? Excellent. Flight modes. So if we talk about things like this drone right here, and we want to fly this drone, it's actually a little bit difficult or different from the previous one. Depending on which flight stack you use, whether it's the PX4 flight stack or the Autopilot flight stack, it will have different flight modes in order for you to actually fly this thing properly. The manual flight mode is pretty much what I just talked to you about before, in which the drone just goes up, down, left, right, back, forwards, depending on your controls. But these other modes here actually assist you in flying. So if you're a beginner, they actually are better for you in order to make sure you don't immediately crash the drone into something. But the downside of using these modes is that they require a GPS signal, because the drone actually uses GPS in order to do things like correct for wind or maintain a constant altitude. So position mode will maintain position at all times, so that when you increase or decrease the throttle, it will slowly climb up or slowly climb down. If you use manual, basically wherever your stick is in your controller, it's going to control the velocity of the drone going up or down. And so it's very, very sensitive and hard to control. Position is kind of like baby mode. It's kind of easier for the drone to know what's going on and to make it so that it's easier to control overall. Hold mode just holds it in the air. And this is actually a good test to see how well your GPS works, because if you flick on hold mode, and usually flight controls are controlled using these switches up here. So for me, hold mode is this. So when I'm flying this drone and I click on hold mode, you'll actually see the drone try to hold itself in the air at all times. And it's basically only using GPS in order to autonomously hold itself in the air. Now, if the drone has a bad GPS or a bad GPS signal, it's going to sway back and forth and sometimes fly into a building. But, you know, hold mode. Autopilot uses the same-ish flight modes. They have stabilized position hold and altitude hold instead of the ones up here. And I use PX4 a lot more, so I know them better, but Autopilot also has documentation as to what each of these things do. Transmitters. Oh, I have one right here. So these get user input data and send them to the drone. And you can use something like this FlySky one right here, or you can use my own controller, in which I made for the Arduino workshop and will actually be using in 2 weeks. But you can also use that to control a drone if you really wanted to, because all it's doing is receiving some user data, processing it, and putting it into the drone. I actually made this to control a drone for my senior design project. We're running out of time, so I'm going to skip this part, but the Mavlink protocol is just representative of the, well, it's a way of sending data to and from a drone from the data transceiver. And if I display this here, this is what goes into each packet. So if you're very interested in seeing how the data goes to and from a quadcopter and how it can process this data, you can dig deeper into this graph, but I'm going to skip it for now. Okay, there's 2 ways of doing autonomous flights. Generally, there's more, but you either can plan a mission within GCS, you can actually use a Raspberry Pi to do so, or you can use the Tello SDK. For today, I don't think we're going to use the Tello SDK, but you can upload code to the DJI Tello and have it autonomously fly on its own. I think that's one of the coolest things about this toy drone, because you can learn Python programming and learn how to fly a drone for just 99 bucks. If any of you have your computer, by the way, you can actually also do this within the code if you feel like you're really good at coding. Okay. How many of you all want a drone now? Raise your hands. Hey, that's good. That's more. It's more than expected. Okay, so you want a drone. Now what? Let's talk about buying drones. So this drone I have here, again, it's the Parrot Anaphis. It's a commercial drone that you can buy. It comes in a package, ready to fly. It's pretty nice. So if you don't want to dig your head over building this thing, you can just buy one of these on Amazon or the websites and get it for free. I mean, not for free. We're talking about for $400. It'd be great if it was free. So the great thing about Parrot Anafi is that it has a great camera. This camera is 1080p, and it's just situated on a drone, and it's also located on gimbal. So you can see this drone has this camera here, which basically is loose. And it's loose because it follows gravity, and it stabilizes itself while it's in the air. You can actually hold and take a look at this. So I'm going to be going ahead and using this drone in order to take pictures in the air. I'm also going to be able to strap a GoPro on this thing, but you want that thing in the air rather than this, because this is like really loud and really dangerous and really hard to control. So I'm going to be taking some air pictures from that drone, which I think is pretty cool. The next drone is the DJI Mavic. Now the Mavic is kind of similar to the Parrot Anafi in which it's a commercial drone. It's made by DJI, which is one of the leading drone companies around the world. Interesting fact, the US actually blacklisted DJI from like sale and distributing them drones because it's a Chinese company and they're worried about safety and security. But DJI makes one of the coolest drones in the planet. So this is a really cool one you can buy for like $300 to $1,000. There's different versions of the DJI Mavic, but really the difference is going to be battery life and camera quality. That's what you're going to be looking for. I think this one's at 4K. 4K resolution. Now, if you want to save on money and you want to get started, you can buy the Telope, which is also by DJI. So they actually released this at CES, the tech conference that happens every single year in Las Vegas. By the way, who has the battery for this? Oh, thank you. And you can get started with flying drones with just this little thing. And you will be able to go ahead and fly using this drone in just a little bit, actually. And the Pixel drone, you got to build it yourself. So if you're very motivated and interested in tinkering with all the individual components we just talked about, you can get your own drone for $1,000, approximately. Might be more because of inflation. I don't know. And if you want to build a Raspberry Pi drone, again, there's no flight computer in this. The Raspberry Pi is the flight computer. This is actually a Pi Zero. So a Pi Zero is around $5 to $10 without inflation. Scalping price is probably like 30, 35. But it's honestly very inexpensive. And I am currently building my own for a class project as well. So this uses Dreamflight, the open source software and firmware that calculates exactly what things are and where things go. So to get started, again, we talked about this before the lecture, but you really want to be careful that you're following the law when you're flying drones, because again, you are flying drones. So there's always the risk of you breaking the law inadvertently if you aren't following the right steps. So to get started with flying drones, have an idea in mind, right? So have an idea of what you want to use the drone for, right? Do you want to take cool pictures from in the air? Do you want to do an automated delivery? Do you want to use it for a senior project, et cetera, right? Then get a drone. So I don't know which drone you want, but whichever one you have in mind, then you get it. So you would purchase it with money or build it, or whatchamacallit. I don't really know how you want to pursue this stuff. After that, take the trust certificate test, which is very important. If you want to fly kind of like this drone, you got to make sure that you are certified by trust, right? Trust is the system, kind of like the driver's permit. You want to make sure you follow all these steps before flying your drone for the first time, because it may sound like a pain to do, but it's actually very, very helpful. It gives you a lot of instructions and safety methods to prevent yourself from crashing into someone or breaking a law or violating something or a building or someone or So you want to be safe when flying, because again, it's a drone, and if you lose control of the drone, which does happen by the way, you want to know how to take care of it. You want to know how you can stop it from destroying the entire world. So be safe, please. Don't fly things that might cause harm, and try not to fly indoors. Unless it's like this drone, you can probably fly this one indoors, but that drone or this drone, don't fly indoors. If you want to fly drones commercially, now for those of you who want to make money off drones, because again, it's a very good business. I mean, if I went ahead and took a parrot and athlete drone and I flew it and took pictures at a wedding, that's an easy like $1,000 right there, right? People love drone photos because A, it's in the air, B, it's like cool and hip and whatnot. So if you want to do that and earn money from flying drones, you need to train for an exam. And the exam is for acquiring a Part 107 license or certificate. You can Google the rest. I'm just going to give you the starting points here. But in case you want to actually fly drones for real as a job, you need this license. Okay, I'm going to skip this part for Tello SDK because we're running out of time. I was going to do a download of the code, but I will say that in the event that one of these Tellos does not connect to the phone app and you can fly it, then we will need to go ahead and use some pre-written code that I wrote to fly the drone. But there is an app on your phone. It's on both Android and on the Apple. So in a bit, I'm going to have you guys download that app into your phone, and then you'll be able to control the drone by connecting to it through Wi-Fi. So the drone racing lab. What are we doing today? I'm very good on time. Before we talk about the actual lab and what we're doing today, we're going to talk about drone safety. I think she was supposed to get in here. So let's make sure you're safe before actually flying the drone, because again, a little bit dangerous. So has everyone signed their liability forms? Yes?
Not come to me afterwards.
Huh?
I said, if not, come to me afterwards.
Yeah, if you have not signed your liability forms, go see Addy. If you don't know what liability forms are, go to Addy. Okay, so in order for you to fly safely, A, make sure there's good weather. I am so glad that today we have clear skies and an open field, because for the past like 3 weeks, that was really rare. Like I couldn't fly before spring break because literally every single day was a rainy day, and you can't fly in the rain for obvious reasons. So make sure there's good weather before you fly. Always retain line of sight, right? Always make sure you can see your drone. Whether it's through a camera or whether you can see it in the air, make sure you know where your drone is. Because if you don't, then you're just controlling who knows what, right? Steer clear of airports for obvious reasons, right? There's planes there. You don't want to fly into planes. That'll be bad. Watch out for interference. Okay, let's go back to the power lines, right? Power lines generate magnetic fields. Magnetic fields can use to power the drone wirelessly, but also magnetic fields do something different. It's called scrambling the drone, right? Because magnetic fields are just wild signals that may cause the flight computer to think a 1's a 0 and a 0's a 1. So that's interference. And usually it's magnetic interference because it's invisible and you can't see it. If you fly your drone near sites of interference, your drone may be uncontrollable, right? That's why I said, if you want to maintain your battery life of the drone by flying it next to a power line, and the power line causes the drone to think that, oh, let me just go fly right into it, you're not going to be able to control that. Like, it grabs control away from you and tosses it into a power line, which basically means goodbye for the drone and the power line, but mainly the drone. Do not fly above people. Well, for obvious reasons, again, you don't want to like fly the drone into a person and have the propellers cause some damage. Do not fly above 400 feet, because above 400 feet, you risk flying into things like birds, mainly birds, and power lines, and things that you should not be flying into. So maintain your small scale drone under 400 feet, which actually 400 feet is very, very, very high. So like, I don't think you'll need anything higher than 400 feet, unless like, I guess you want to fly over the Empire State Building. I don't know. Do not fly above major roads. Like, don't fly over a freeway unless you get permission, right? Because who knows, you might like crash your drone into a car and kill someone. So don't do that, please. Do not fly above military bases for obvious reasons. I know you might want to figure out what's inside Area 51, but they might shoot your drone down before you get close. So I had to put this here. Hey, this was on the rules, like I looked at. So
You're gonna be like
Okay, so we're finally going to talk about the drone racing lab. Now that we all know what to do and how to be safe, what are you going to be doing today? You have 2 hours starting from now. We're going to end at 6:30. 6:30 is when we're going to be doing the race, by the way. And you're going to just practice flying the drone through mounted rings. So when we get out there, we're going to set up 9 of these rings. These rings right here. I 3D printed these last night. Ooh. So these rings are 600 millimeter rings, and they will basically determine places that you should fly your drone through. So you're going to fly the drone through these rings like this, and that counts as like a pass. I don't know if you ever like played Wii Sports or like this is based on that. So you're going to practice positioning, flying the drone, manually controlling it through said rings. And you're going to experiment with sensitivity, control, and acro modes. So the Tello has this cool little mode. If you get to controlling it with like your phone, you'll notice that it has something called sports mode. And sports mode is going to make the drone fly like it's on steroids. And the drone's going to go up to 8 miles per hour, which makes it more uncontrollable. But if you want to win the race, you're going to have to do flying sport mode. So that's what we're going to have to accomplish today. Program your drone with the Tello SDK. If you get bored of flying drones, which I don't know, why would you? You can go ahead and program it with the Tello code, which you can look up with Python if you want to. Now, if you don't know anything about coding, don't worry about it. So we're racing at 6:30 p.m. All teams are going to race at the same time. So I don't know if we're going to be able to do this. I don't know how many people we actually have. Let me just count real quick. Okay. So we have about 17 people, 16 people, 15 people. I'm going to say 15, 15 to 17 people. And we have 5 drones. So I think what we're going to have is teams of 3 to 4. And we're going to assign the teams when we get out there. So we're going to go to the engineering meta, which we're going to peek right now. Yes, it is. Okay. So we're going to group you into teams, and we're going to give you a drone. Now, before you fly the drone, we're going to figure out what Wi-Fi it's on, because all the Wi-Fi things have different names. So your drone will get a specific 2-digit or 2-character number and letter, like D9 or A4, that determines the last 2 digits of the Wi-Fi. So as we figure that out, we'll go ahead and distribute the drones to you, and then you get to start flying it. Oh, also, it might not be best of 5, it might be best of 3, but we're going to have it so that all drones are flying at the same time through these obstacle course at the end, and you're going to have different pilots each time. So make sure everyone in your group knows how to fly at the end. That's the goal. So the ring race is, we're going to give each team a ring to practice, or maybe 2 if we have enough. And at the end, we're going to create a whole obstacle course going all the way through the engineering meadow. It's going to be 9 different colored rings, and you have to traverse through them in this order. So it's going to go black first, and then red, gold, green, transparent blue, regular blue, purple, silver, and black. And so they'll be spaced out very far from each other, maybe like 20, 30 feet, and you'll just fly through them. You'll follow the drone because you want to make sure you don't lose transmission. And the first team, or the first drone to reach the end, wins that round. We're going to have multiple rounds, that's why. And the first team to reach 3 points, 5 points, however many we decide, will win a special trophy. It's personalized too. Oh yeah, if you crash, you get disqualified.
Oh.
So there are multiple ways you can crash. These Teledrones are very sensitive to crashing, which is good. So they will crash in multiple circumstances. If you hit a wall, it will crash. If you hit another drone, it will crash. If you hit the tripod instead of the ring, it will crash. So if it detects anything that's out of the ordinary, it will crash. So you'll be disqualified from that round if it crashes. So try not to do that. But we make like 3 drones run at the same time, so I think that's already pretty fun. Okay, I think that's it for now. We're gonna go ahead and transition to the engineering meadow. So for everyone here, if you haven't signed liability waivers, see Addy. If you haven't signed into the workshop, see Addy. Otherwise, let's meet in front of building 9. Yes?
Is the order of the rings going to be pushed?
Yeah, it'll be very obvious what the order of the rings are. So go ahead and just meet us in front of building 9, near the engineering meadow, near that big rock, and we'll be there in a second. Thank you. Are we flying this one?